Okay, so in this spell work here, I'm going to graph two quadratic equations. Now this first one here has a equation where it has three terms and no parentheses. So we call this one standard form. So this one's standard form, and it's because standard form is generally written where you can see the equation, the quadratic, as x squared and then a number in front, and then b being a coefficient in front of x to the first power, and then your constant at the very end. Now you can see here that your a, or your coefficient in front of x squared, is a 1. So that's our A. Our B here is a negative 1 because there's a negative sign in front. And C here is negative 6. So we said that with standard form, the advantages is that you can graph the Y-intercept very easily because it's your C. So your C here is a negative 6. So I'm going to go on the Y-axis and I'm going to graph it at negative 6. And so once I plot this, I have my y-intercept. So I have 1 point on this coordinate system. I need 2 more points because for a quadratic, I need to plot at least 3 points here. So we usually want to plot the vertex. Now, finding the vertex for standard form is a little bit more tricky. What you have to do is use a formula here. And our formula is where we take x and we take the negative b. So the negative, in this case, b is your coefficient in the equation, and we put it over to a. So we're going to grab b here, which is negative 1. Notice how the equation already has a negative, so if you plug in negative 1, you're going to get a positive. Whereas the bottom, or the denominator here, is you're going to do 2 times your a, which is 1. So this is really positive 1/2, or we can write this as 0.5 just to make the plugging in part a little easier. So that piece is our vertex. So if I were to keep track of this, my vertex is 0.5 for the x value. Now I need to find the y value. So to do that, I'm going to grab this number here, plug it into the equation, see what I get. So this is going to be y equals 0.5 squared minus 0.5 minus 6. So all I did was take this x value, plug it in for the equation. Now I'm about to work it out. So 0.5 squared is 0.25. I'm going to subtract it by the 0.5 and then the 6. If I were to do this, I get negative 6.25, I think. So in this case here, this is our y value. So I'm going to stick it into this equation as negative 2.5. And if I were to graph this, this would be about half this way, so 0.5, and then down, right, to 6.25, which would be around here, like a little bit lower than negative 6, but only between 0 and 1 because it's 0.5 for x. And then I would try to reflect it to the other side, and it's going to be right around there. So I'm going to reflect the y-intercept and graph. And so when I graph this, I notice that, well, I'm looking for x-intercept. So I'm going to see where does this parabola hit the x-axis, because that's where x-intercepts are. And so in this case, it hit it here and here. So this is going to be at negative 2, 0, and at 2, 0. Now these might not be the exact x-intercept if I were to solve this out algebraically, but graphing wise, this is where it hit. So let me just say right now that graphing is an estimation, or how do you estimate your x-intercepts using this technique. So graphing only gives you estimates, not the exact answer. And in next week's lesson, I'll teach you how to get the exact x-intercepts, or the exact x values. So in this case, my picture might look different from your picture depending on how you draw your curves. But for me, it hit at x equals negative 2 and at x equals positive 2. And it's totally fine if you got different points. What I want to see is, did you calculate the other 3 points correctly? Okay? Did you get the y-intercept? Did you reflect it correctly? Did you get the vertex correctly? Those are things that I'm going to be looking for in your skills, not necessarily your end answer. All right, so that's standard form. That one we take to find the vertex, we use this formula, and to get an extra point, we use the Y-intercept and then reflect it. This one here, you can see there are parentheses, so this is what we call vertex form. So with vertex form, what you can easily do is use your shift. So this one says -2, which means right 2. And then -1 on the outside means down 1. So if I go right 2 from the origin and down 1, it hits about right here. So that's where my vertex is. And then from the rest, I want to use the slope. So the slope here, or the number in front of the parentheses, the slope here is 1. So I can write that as 1 over 1. So in this case, you're going up 1 over 1 for the slope, and then you would go up 1 over 1 to the left to reflect it, and then graph your curves. And so looking at this here, this picture, and because it was in vertex form, this one probably was a little bit easier to graph. The vertex was easier to find because you don't have to use a formula, you just use a shift. But you can see here that it hits it at 3 and 1. So this is at 1 and 0. And this is at 3 and 0. So this one hit really nicely just because the slope worked out pretty well. That's not always the case for vertex form, it's just that this case did work out nicer. So there are some graphing where I think, in my personal opinion, it's easier to just graph it because you might just end up with a nice pretty picture because the slope works out well for you or the points work out well for you. And then there are other cases where it doesn't. So I wanted you to see these two differences just to see the advantages and disadvantages. All right, now let's get into today's lesson, which is all about factoring. And factoring is really the skill that will help us solve for x, especially when we have a quadratic equation. Okay, so one of the things about factoring is that you have to find the greatest common factor. And what that means is the largest term that factors out of all of the terms in your polynomial or in your many terms expression. So in this case, you have two terms. If you guys remember in Algebra 2, we call two terms a binomial. Bi meaning two, nomial meaning terms. So in this case, you're going to factor out the greatest common factor, or basically the biggest number you can divide out of each term. So here I have a 12m, and this one is a 60. Now, first off, they don't both have m, so I'm not dragging out an m out of here. But 12 and 60, they have some numbers in common that you can divide out. So 12 you can divide out of 6, and you can also divide out of 6 out of 60, but there's a bigger number you can divide out. And the number that I see here is the 12. So I can divide out 12 out of both of these. So I'm going to drag out a 12. That means I leave something behind. If I divide this by 12, that means m is left behind. And then I'm going to carry down the minus sign. If I divide 60 out of 12, that's going to be a 5 left over. So that means that in this parentheses, I have in the first term left over an m, the second term here, a negative 5. And then the 12 gets to sit out here. So what you're doing is that you're creating parentheses to show what is left over. But here's the thing. That 12 that sits out of the parentheses, that is a multiplication. You can multiply or distribute that back in to get what you originally started with. So factoring out things is almost like you're undoing your distribution, or you're dividing out the factor that you distribute in. So this next one here, I want us to just focus on the 8 and the 24 first, basically the coefficients first. So 8 and 24, what is the biggest number that divides into 8 and 24? Well, it's 8, right? 8 divides into 8. So if I drag out an 8, I'm going to be able to divide that piece, the first term, by 8 and the 24 by 8. But before I do that, let's look at the k's here. So this k is to the third power, where this k is to the first power. When you compare these two, the lowest amount of power is the k that you'll bring out, the how many k's you'll bring out. So in this case, this is k to the third, this is k to the first, this is the lowest one, so I can bring out at least 1k. So when I look at this piece here, I already divided out the 8 or dragged out the 8, and I've already dragged out one of the k's. So in the first term, I only have 2 k's left, or k squared. Bring down the plus sign. This one here, I took out an 8, so I'm dividing this 24 by 8, so I only have a 3 left. And then I already dragged out a k, so that means I don't have any more k's left. So this is it. That's all I can really factor out. All right, so let's try out some other problems that have more variety to them. So in this one here, you have 3 terms, and check out the numbers. You have a 21, a 35, and a 14. What do they all divide by? Just take a moment to think about it. All right, they all divide by 7. So in this case here, if I divide out 7, I would have a 3 left over here. 21 divided by 7 is 3. 35 divided by 7 is 5. And 14 divided by 7 is 2. The next thing I want to look at is the x's. The lowest amount of x's that I have here is x to the third power. They all have x's, but x to the third power is the lowest one, so that means I can drag out at least x to the third power, or factor out at least x to the third power. Now, remember here, we already divided this 21 by 7, and we got a 3, but we took out 3 of the x's, so that means if this is to the 5th power, we have 2 more left. So this is x to the square, or x to the 2nd power. The next one here, we divided 35 by 7, and we got 5 left over. We're taking 3 of the x's out of this x to the 4th, so that means 1 x is left behind. The next term here, you still have a negative 2 left because you divided the 14 by 7. And then if you drag out x to the third from this term, you don't have any x's left. So this is it. Let me move my parentheses a little closer like that. There we go. And so this here is our final answer because I can't really factor any more out, right? Because 3, 5, and 2 don't have anything in common. Neither do these. I can't drag out any x's because that 2 doesn't have an x. So this is my final answer. All right, in the next one here, I have 3 terms, and that's a 15, 27, and a 36. So in this case here, the number that goes into all of these numbers is, I think, a 3. So I can drag out a 3. Let me drag out a 3. And so if I drag out a 3 here, I would divide the 15 by 3, which becomes 5. I would divide the 27 by 3, which is 9. And I would divide the 36 by 3, which is 12. Yeah. So then I'm going to look at the y's here. So this one's y to the third squared and y to the first power. So in this case, y to the first power is the lowest one, so I'm going to at least drag out y to the first power. You don't have to write a 1 there for y. I just did, just to remember. So then you have your z's, not x's, my bad. The z's here, the lowest power here is z to the third power. So I'm going to drag out z to the third power. All right, now if I go back into this, 5 was the coefficient in the first term that's left behind. If I drag out 1 y, that means 2 are left, so y squared. And then z here, I took out all 3 of them, so there's no more z's left in the first term. The next one here, I have a 9 left over after I divide by a 3. And then I took out 1 of the y's, so I still have 1 y left. And I took out 3 of the z's, so I still have 1 z left. And then the third term here, I have a 12 left. This one only had 1 y, and I took that one out, so I don't have any y's left. And then the z here, I took out 3 of them, so there's still 2 z's left. So z to squared is left over. And that's really all that I can do here, because 5, 9, and 12 don't really have anything in common, and they all have like different amount of variables now. All right, so that's it for the number 16. By the way, these are homework problems from the textbook that I'm picking out for us to try out. Okay, so this next one here is a little tricky because some of them are already in parentheses, right? Like this group is in parentheses and this group's in parentheses. But what I want us to think about is use the parentheses like they are a collected unit. So take a look at this term versus this term. You're always comparing terms when you are factoring out your greatest common factor. What do both of these terms have? They both have z minus 5, right? So that means you can take out a z minus 5. And when you do, you eliminate this off of each term, right? Leaving behind these two terms, which are not identical, so they're left behind. So in your first term here, you have a z plus 7. And in your second one, so I'm going to bring down that plus sign here. And in your second term, you're left behind a z plus 9. And so when I look at these two here, I notice that, well, this one I can't really do much. It's already inside parentheses. This one I can like combine some like terms. Like that's a z, that's a z. If I combine them, that becomes, well, that's a 1, that's a 1. So that's a 2z. Plus 7 plus 9 gives me 16. I'm going to drag down the z minus 5. But then I also notice that's a 2 and that's a 16. And those are like, they have some common factors. Like what number goes into 2 and 16? Well, it's 2. So because I noticed that I can drag out a common factor, I'm going to drag out that number, which is a 2. And I'll stick it in the front, just kind of looks nicer in the front. So I'm going to bring down the z minus 5. And then if I factor out a 2 from here, I'm just left with a z. If I factor out a 2 out of 16, I'm just left with an 8. And then looking at this here, I don't think I can factor out anymore. There's no more coefficients. Well, the coefficient in front is just a 1, so I don't really have anything in common to factor out at this point. So this is it. All right. And then this one here has 4 terms. Anytime you have 4 terms, I want you to try to use something called grouping. Grouping is a technique where you take 2 of your terms out of the 4 and put them together. It doesn't matter which one you decide to put together. I usually like to put like the first 2 together and attempt to factor. And I'll show you what I mean in a minute. And then put the last 2 in a parentheses. So you put the first 2 in parentheses and the last 2 in parentheses and attempt to factor. If that doesn't work, you can try to switch around the terms until you can get something to factor. But the idea is like if you have 4 terms or more, you can put them in its own parentheses. You create the parentheses and try to bring out numbers. And that's usually easier because you're only working with 2 terms at a time. So if you look at this first parentheses here, I notice that they both have a y. So I'm going to drag out a y, which means that I leave behind a 2x and a 3. Whereas this next one here, that's a 2x, that's a 3. There's really nothing I can drag out. So I'm just going to bring down the 2x plus 3. But then what I noticed is when I bring everything down, there's a 2x plus 3 and there's another 2x plus 3 in both of the terms, right? There are only 2 terms here now, this term, and they both have a 2x plus 3. So guess what? We can bring that 2x plus 3 out as its own factor. So we're going to bring it out in parentheses, and we're going to show what's left behind. So this one here has, in the first term, if you take out 2x plus 3, you're left with a y. So I'm going to bring down a y. I'm going to bring down the plus sign here that's in the middle. And then this one here, you took the 2x plus 3, so it looks like you have nothing left over. But if you really think about it, there's really a 1 left over, or a 1 in front of this parentheses. So you're not leaving behind nothing, you're actually leaving behind 1. So keep that in mind. There's always something in front of parentheses, and it's always 1. And also that makes sense because if you're taking out this 2x plus 3, what you're really doing is you're dividing it by 2x plus 3, which ends up giving you 1. Anything divided by itself is 1. All right, then from here, I really don't think there's much else I can factor, right? These 2, I don't have anything more else that I can drag out. Neither can I drag out anything from y plus 1. So this is my final answer. All right, so kind of to summarize all that we've learned, what I want you guys to know from today is how to factor out greatest common factors. And that's looking for the biggest number that divides in each term or the lowest power that divides from each term. I also want you to think about when you have 4 terms or more to use the grouping method where you stick or pair up 2 things in a parentheses, 2 terms in a parentheses. All right, that's it for today, guys. I'm going to go straight into the exit ticket to help you guys practice. Okay, so in this exit ticket today, you have 3 different problems that you'll need to factor. So show me that you can factor out the greatest common factor and show me that you know what leaves are left behind. I also want to mention, to give you a little tip, be here. When you have something like this, right, and you have 2 terms and you notice they don't have anything in common, 8 and 15, think about it. They don't have any numbers in common that they can factor out. Like 8's an even number, 15's an odd number. You can divide in 3 and 5, but those are no numbers that 8 can be divided by. So sometimes when you can't factor out anything, we just call them not factorable. Or we just can't factor them. So keep in mind, not everything needs to be factorable, and you need to be able to tell when you can factor and when you can't, and just to leave it alone. Okay, so I'll just give it to you here. For B, it's not factorable. C, I'll give you a hint. There are 4 terms, so you might want to try grouping to help you out, where you try to pair up 2 terms together and try to factor out from there. This one here is just an ordinary factoring. See what goes into 9 and 81 and what is the lowest power Z to come out. All right, I hope that helps you out in this video today. I hope you have a great day. Bye, guys.